I've been working with the RTView for Optovue OCT for quite some time. We initially employed it as part of our corneal collagen cross-linking studies. We noticed how accurate it was in measuring epithelial thickness. So we employed it to understand some of the nuances of corneal collagen cross-linking, the relationship of the corneal contour in keratoconus eyes, how it gets that way, why the cornea steepens shortly after cross-linking and whatnot. So it was really an addition to our armamentarium. Another use that we found for it was the location of corneal flaps in post-refractive eyes, ones that were referred to us where we didn't know the exact flap thickness. We were able to identify the flap interface in many of these with a resolution that was unavailable in other devices. So that was my introduction to it. More recently, we have started to use it as a method for determining total corneal power, which is in part the subject matter for our discussion today. And so most of you know that the cornea has two refractive surfaces, the anterior surface and the posterior surface. Traditionally, and back in the old days, we used keratometers to measure the corneal power. In doing so, the keratometer made a couple of assumptions. One is that the corneal power was consistent across the surface, so that if you measured the corneal power with a diameter of about 3 millimeters, that could be generalized to the entire cornea. That measures the anterior corneal power. We have to make assumptions about the posterior corneal power, and we have to make assumptions about the distribution of the curvature. Then we learned about topography so that we could look at the front surface generally and learn more about it. But the missing part of the puzzle there is the posterior corneal power. The posterior corneal power is measurable by the OCT. As we move to an area of refractive cataract surgery, this is becoming much more important because our patients are demanding much more accuracy in what we do. In the world of toric lenses, we need to be able to determine not only what the anterior corneal toricity is like, but the posterior corneal toricity. So there are many applications in today's more precise environment than there have ever been in the past. Corneal refractive surgery is one of the areas where where the OCT is especially applicable. In corneal refractive surgery, we alter the anterior curvature of the cornea. So that makes assumptions that have traditionally been made about the relationship between the anterior corneal power and the posterior corneal power incorrect. And this is the reason we have difficulties in determining the proper intraocular lens power for these eyes. So to summarize what I've said, this illustration here talks about measurement of the anterior corneal power, here with the Myers of a traditional keratometer with a green light in the world of topography, with extrapolation of the posterior surface. So if we take a patient who has had myopic LASIK, the anterior surface is going to be flatter than what it was preoperatively, but the posterior surface will be largely unchanged. And therefore, we have difficulties in determining the corneal power for intraocular lens power calculations in these patients. So this is a good place to start to utilize the capabilities of the Optovue to solve our problems. Let's take a look at the accuracy of measurement in comparison with other instruments. Here's ultrasound up here, Scheimpflug up here, and an OCT here, which has about 3 times the resolution of the Pentacam. Here we see a LASIK flap in a Pentacam, and here's the same patient with an Optovue. And as you can see here, we can see Bowman's layer, we can see the thickness of the epithelium, and we can see the flap interface, which is not possible for Scheimpflug devices. The corneal power can be measured reproducibly with the OCT. These are normal eyes showing the mean, standard error, and the pooled standard deviation. So you can see it's accurate to within about 0.2 diopters. It also has excellent reproducibility in post-LASIK eyes with a standard deviation that's about the same. So it is reproducible and also more robust because it can measure both the anterior and the posterior corneal powers. It can also measure corneal powers across the cornea in corneas that have a regular astigmatism for whatever reason. So here's the pachymetry report, and here is the anterior and posterior corneal power within the central 3 millimeters. This paper by Tang is a very good illustration of the capabilities of the system. It looks at the prediction of IOL power using an IOL master and all of the formulas that were associated with the IOL master, selecting the best of those, which was the Haigest, comparing it with the IOL master after myopic laser vision correction. The mean absolute error was significantly lower for the OCT than it was for the IOL master. These are the numbers after hyperopic laser vision correction. The mean absolute error here is also lower. And as most of you are aware, there are a number of methods for calculating IOL powers after refractive surgery. Clinical history, contact lens over refraction, IOL master, orb scan. And here those are on that same population of eyes with a mean absolute error ranging all the way up to 1.78 from the clinical history. And here is the OCT. So that compares much more favorably than the other methods of determining IOL powers. So I set upon using this in my own clinic when it first became available. And these are my initial experience with 5 eyes. These are patients with post-corneal refractive surgery undergoing cataract surgery. We weren't quite as good on this group as we were with the numbers that I just showed you. There were some challenging cases here. And there were some long eyes and also some reasonably short eyes. When I calculate the IOL power for these eyes, I use 18 different formulas, including contact lens over refraction, clinical history, the Holiday Pentacam measurements. So when we began to do this years ago and published a couple of papers on it, we began a spreadsheet and simply added to it as the literature became available. So it now takes about 30 minutes for us to calculate an IOL power for a post-refractive case, including collection of all the data, analysis of all the data, entry of all the data. And so here are the comparisons, the mean absolute error with our methodology of doing it at 0.98, and here it is with our initial 5 cases with the OCT, 0.91. This represents about 30 minutes of work for each patient. This represents about 2 minutes of work for each patient. So I look forward to collecting more data to verify the advantages, but I can tell you one huge advantage right at the start, and that is it's a whole lot faster, and it appears to be much more accurate as well. So confirming the findings reported in the Wang paper, it looks like this is going to be a welcome addition to our armamentarium for taking care of these difficult patients in the future.